So this is the 2018 Leaving Cert Ordinary Level Paper 1, and we're looking at question number 2. Z1 is equal to minus 2 plus 3i, and Z2 is equal to minus 3 minus 2i, where I squared is equal to negative 1. Z3 is equal to Z1 minus Z2. So part A asks us to plot Z1, Z2 and Z3 on the Argand diagram and label each point clearly. Okay, well, Z1 is minus 2 plus 3i, so starting from the origin, we go minus 2 in the real direction and up 3 in the imaginary. So there's our Z1. Z2 is minus 3 minus 2i, minus 3 minus 2i. Which is here, that's Z2. And Z3 is equal to Z1 minus Z2, so Z1 and then subtract Z2. So if we subtract vertically, it's a bit easier to avoid mistakes. So minus 2 minus minus 3, that's 1. Do that in the calculator if you need to. 3 minus minus 2i, that's actually 3 plus 2i, which is, sorry, that should be 3i there. 3i plus 2i, which is 5i. So 1 plus 5i is Z3. That's 1 plus 5i, which is Z3. Part B asks us to investigate if the modulus of Z3, these straight brackets here mean modulus, the distance from the origin, is equal to the modulus of Z1 plus the modulus of Z2. So we have to find out the modulus of all three complex numbers. That's just Z3, modulus of Z3. So the modulus of Z3, what they mean there is they want to know what's the distance from the origin to the complex number Z3. What's that distance? Well, we can do this by having a look at the triangle underneath it, which is right angled. So we can just do Pythagoras on this. So you've got this height here of the triangle, which is 5, and this is 1. So we're going to be looking at the triangle like this. That's 1, that's 5, and we're looking for, let's call it A. A is the modulus, let's say, of Z3. So we can say that A squared is equal to 1 squared plus 5 squared. So A squared is equal to 1 plus 25, which is 26. So A is root 26. And on your calculator, root 26 simplifies. No, it doesn't. It's just root 26. Okay, so root 26, I'll just highlight this so it's nice and clear. The modulus of Z3 is root 26. Okay. So then I'm going to find the modulus of Z1. Well, where's Z1? The modulus of Z1 is the length of this line here, from the complex number back to the origin. So I'm looking at this triangle now, which is right angled, just like the other one was. And this triangle here has a height of 3 and a run of 2. So we've got a height of 3 and a run of 2. That's 3, that's 2, it's a right angle. And this time we're looking for, we'll call it B this time. So B squared is equal to 3 squared plus 2 squared. B squared is equal to 9 plus 4, which is 13. So B is root 13. So just again, so we're clear, the modulus of Z1 is root 13. Okay, finally, we're going to look for the modulus of Z2. So that's from here back to the origin. So the triangle we want to look at here is this triangle. Now you could look at it this way as well, but we'll keep going back to the real axis. So this triangle here, it's right angled. It's got a rise of 2 and a run of 3. So this time we're looking at a rise 2 and a run of 3. So it's actually the same triangle as this one here, it's just on its side. So we already know that this side here will be the same as that one, which is root 13. So C here, we'll call it C, is root 13. So C, which we can do in blue, the modulus of Z2 is root 13 also. So the question it asks us is the yellow equal to the green plus the blue? So what's that saying? That's saying, is root 26, is that equal to root 13 plus root 13? That's, is the yellow equal to the green plus the blue? And that is you can check this in your calculator, but that's root 13 and root 13 is just 2 root 13. I suppose we should make this question. Is this equal to that? Well, you can do this in your calculator. Root 26, if you express it as a decimal, is 5.09, and 2 root 13, if you express it as a decimal, is 7.21. So the answer here is that it's not equal to that. So root 26 is not equal. You can use the not equal to sign. The conclusion, no, it's not equal to it. Okay. Finally then, part C. Z4 is equal to Z1 over Z2. Write Z4 in the form x plus yi, where x and y are real numbers. Okay, so Z4, which we haven't heard of yet, but we know it's equal to the complex number Z1, which was minus 2 plus 3i, over the complex number Z2, which was minus 3 minus 2i. Right, and we have to express this as a complex number with a real and imaginary part. Well, this is the division of complex numbers here. So if you remember, the method we use to divide complex numbers is we multiply above and below by the conjugate of the bottom. So the conjugate of this is minus 3 plus 2i. And we multiply the top by the exact same thing. So the reason we do this is because the bottom, when you multiply a complex number by its conjugate, it becomes a real number, or the imaginary bit becomes 0. So we can do the top here, and we can do the bottom over there, and we can bring them back together at the end, express them as a fraction. Okay, so minus 2 plus 3i by minus 3 plus 2i. So we're going to multiply this out. Multiply the minus 2 by both and the 3i by both of these. So that's going to give me minus 2 by minus 3 is 6. Minus 2 by 2i is minus 4i. 3i by minus 3 is minus 9i. And 3i by 2i is 6i squared, positive 6i squared. So tidying this up, we have 6. The I bits we can combine. Minus 4i minus 9i is minus 13i. Remember, I squared is negative 1. This was given in the question at the beginning. So we replace the I squared with a negative 1. So that gives us 6 minus 13i. 6 by minus 1 is minus 6. And the 6 and the minus 6 here cancel, leaving me with just negative 13i. Okay, so now the bottom, it's minus 3 minus 2i by minus 3 plus 2i. So multiplying minus 3 by both of these first, we get minus 3 by minus 3 is 9, minus 3 by 2i is minus 6i. And then we can multiply the minus 2i by both of these. Minus 2i by minus 3 is plus 6i. And minus 2i by plus 2i is minus 4i squared. So that gives us this minus 6i and the 6i will cancel. We were expecting that. That's why we multiplied by the conjugate. So we end up with 9 minus 4i squared, but I squared is negative 1. So that actually becomes 9 minus 4 by minus 1 is plus 4, which is 13. So that's the top, that's the bottom, top, bottom. Now we've got to bring them back together. So you got minus 13i on top over 13. And that is equal to minus 1i. So you might think, well, minus 1i isn't in this form, but it is if we allow x to be 0. That's the same as 0 minus 1i, or 0 minus I. Because 0 and minus 1, x and y, are real numbers. And that's the end of the question.